Hi, my name is Jamal Ashraf, and I want to talk about linked list. I divided in a few parts, and we're going to be using Python to go over the linked list, the data structure part. So we're going to be uh, talking about it in smaller portions. Let's go over this one. Okay, so first we're going to be talking about the singly linked list. We're going to go overview. We're going to talk about the insertion, and we're going to talk about the deletion, and we're going to talk about efficiency. So basically, what we have with the linked list is we have nodes that's going to be connected to a list, and they're going to be connected to each other, and we have some kind of a connection with them. Okay, we can talk about pointers, we can talk about the address. So they are connected to each other. Uh, so the first one is going to be the head, and the last one is going to be called tail, and our list is going to point to the head and also is going to point to the tail to have a reference to the beginning and to the end of our list, the one that we are working on it. And the null or none in here in Python, they call it none, but it's a null. So basically that means every time you create an object, it's going to have its own address. So we're going to be working with the objects which are created from classes. If you are not familiar with classes, we're going to talk about those in a different video. I have put some stuff in the class for class and inheritance. So when we're creating an object, we are going to be making an object of a class. So object is the existence of a class, and it's going to sit in the memory. But if I just have a name and it doesn't reference to any object, that would be called the null pointer or the address of null, meaning that I would have a name of the object, but it's not pointing to anywhere. I'm going to talk more about that. So in this case, we are looking at a num list. So to do that, let me get my annotation up. And so we are going to create a new list. This is the way we're going to create an object of a list. So we're going to create a new list. Of course, we're going to go over how we're going to create these things. And then we're going to add 1 and 2 to this list. And we're going to add 1 to the beginning of the list. So we're going to talk about all these methods and the functions, method or function, depending on what language you're coming from. And that's what we're doing in here. So we have a data and we have a pointer to the next one. So if we're looking at each node that we are looking at, we're going to have a data section and we're going to have a pointer that's going to be pointing to the next one. And that's going to be our node structure. So we generally have a list structure that's going to start with the first or the head, and then it's going to the last one. We're going to call it tail or last, whatever you want to call it. So we are talking about a type of a positional list and elements which are nodes, and sometimes there are previous elements in the sequence. We can have those as a subsequence. And we talked about the null pointer, which is going to be pointing to nowhere. So generally the last one, the tail, the next in there is going to be pointing to null. So that's one way of knowing or checking to see what's going on. So for our list, we're going to have a tail to the last one. The next of the first one is going to be pointing to the next second one. The second one is going to be pointing to the third one, and so on and so forth. The last one is going to have the null pointer for the next. So how do we implement this? The implementation, remember, is going to be creating an object. So we are working with the class definition of node first, and then we're going to be talking about the list after that. So in general, for the node, we have data and we have next. And the way that we're going to start our class, we're going to have our initial data that is coming to us through the parameter. Remember, self is a way of Python to keep track of itself, the object. Remember, Python is a scripting language, so it's not easy for it to know where it is. So when we're using self, it's basically a pointer to itself. So generally, we go to the second one and we work on those. So we're going to take the initial data, we're going to put it in this data over here. And in this case, we have the next one to none. So we're just going to put the data and it's pointing to nowhere. So that's the way our class definition is. And every time we have a class, we have to create an object of that class to be able to use it. So we're going to call node 95. We're passing 95 to this object. So we are calling or creating an node, and then we're adding the data 95. So 95 is going to go for our data. And as we saw over here, we're going to send our next to null. That's the way it's going to be, our object is going to be created for this particular one. So the other class that we need is called a linked list, or we can call it what we want. And this one, it's going to have a head and it's going to have a tail. So the head is supposed to be pointing to the first one in the list, and the tail is going to be pointing to the last one in the list. So basically, this one is keeping track of all the nodes, where they are, where we are starting, where we are ending. So if I create a linked list, this is the object of the linked list. So it's going to create an object of it. We're going to assign the address of that object to our variable called num list. And both of these, head and tail, are going to be empty. So we're going to insert null. So we're going to insert null for the tail. We're going to insert the null for the head, and the object of anomalies has been created. Okay, so when we have a linked list, we're going to add nodes. So we're going to have nodes. Remember, we have to create them before we use them. The class itself, you cannot use it. You have to create an object of a class before you be able to use it. So now that we have node and we have linked list, how do we connect them together? We're going to use something called append. So or we can call it insertion. So we have different way of inserting a node into a list. So append is going to be the part of the linked list class, and that's going to be its primary job is to add a node to the end of the list. So every time we call the append, it's going to receive a node, it's going to put it at the end of the list. So it's going to take two parameters. So it's going to take two parameters. Remember, the first one is always going to be self for referring to the current object. And the second one is going to be the new node. So we're going to receive a new node as an object, and we're going to add it to our list at the end of our list. So the method definition is going to be append, and we're going to have it later on. And the self parameter, of course, is going to be pointing to the object itself. So let's look at the append method. So we're going to be looking at append method. So the definition of it, remember, this is part of my linked list. So it is going to, just a reminder, our linked list is going to have what? It's going to have a head and it's going to have a tail. And head and tail, when you initially create your linked list, is going to be pointing to none. Okay, so we're going to have this method. So we're getting a node coming in as an object. So we already created this node. And then when we get it, we're going to check it to see if the head is none or not. So why do we do that? Because if it's empty, we're going to be putting the head and tail pointing to that node. If it's not empty, we're going to go to the end of the list. We're going to put the node to the end of the list, and we're going to update our tail. So that's the way we're going to be doing it. So let's execute this method to see what happens. So first, initially, we're going to have an empty list for the num list that we created above. And the head and the point are pointing to null, so it's not pointing to anywhere. Then we're going to be calling this append. So first, before we call the append, we have to create our object. So node A is going to be created by just calling this. So I'm creating an object of node A with the data of 99, and the next is going to be null. And then we're going to create another node called node B, and we're going to put the value of 42 in it, and then we're going to put the next as a node. So right now I have three objects: num list, node A, node B. Now, if I use the append for node A, it's going to go and look at the here. So we are here. Our head was pointing to null, none or null. So what's going to happen is we're going to point the head to our new node, and we're going to put the tail for our new node, meaning that the new node is going to be both head and tail at the same time, because we only have one element right now. So that's going to be my list. Now, we're going to go on and we're going to do the second one. So when we're doing the second one is going to do what? It's going to come into the same method. It's going to look at this. The head is not none anymore because the head is pointing to node A. So it's going to skip this. It's going to come here. It's going to say that the tail next is equal to new node. Remember, the tail was here. If I go up, so we are going here. We're going to say the tail next is going to go point to this new one. So our tail is going to be pointing to that. And our tail here is going to be updated to the new one. So we are using tail next to point to this one. We're going to be using the tail to be pointing to this last one. So that's the way we're going to have our list right now after two insertion. We are using append, and append is just going to put it at the end of our list. So this is another way of looking at it. So we would have our linked list that's going to have our head and tail in there, and it's going to be pointing to the node. So we're going to create a node and we're going to add to it. Of course, this one is adding to the first. We're going to be looking at that one for the next slide. So another way of adding something to our list, so remember the previous one would be adding to the last, to the tail. But there is another way, and that is adding to the beginning. So in this case, we're going to create a node. We're going to put our data in there. We're going to point our head to this node, and we're going to put the next to this, the next. So remember, right now, our first or our head is pointing to this one. So what we need to do is, if I point my first or my head to this new one, I already lost the other ones. So I have to be careful not to lose this one. So I have to point the next of this one first before I update my head. Otherwise, we're going to be losing the list. So again, we're going to have two conditions. The prepend is going to be adding first or at the beginning. So we're going to have two conditions. Again, if the head is none, then we're just going to put it right there. That means it's an empty list. So the first part here is for empty list. And the second part is if we already have a list. So let's look at it. So if I have a empty list, I'm going to be creating a node A. I'm going to create a node A over here. So right now I have created an object of my list. I have created an object of my node. So when I go through this prepend, it's going to check to see if it's none, which is none at this case. Both of these are none because it's empty. Initially, we could put a none. So what do we do? We're going to put the head to this one. I'm going to put the tail to this one. So this would not be any different than the previous one. We're going to create another object. We're going to put the data of 42. Again, the next is going to be pointing to, it's going to be pointing to null. So we are adding node A. So node A is going to be both head and tail, and it's going to be just a list of one node. So when we adding node B, remember what we're going to do. We're going to put the head to node B. We're going to put the next of node B before we apply that. And then we're going to put the, so it says new node.next, new node.x equal the self head. So head is pointing to this one. We're going to do the next first. Otherwise, we're going to be losing our list. And then we're going to do what? We're going to point the head to this new one. And this is the way we're going to have. And of course, the tail is going to be A, the head is going to be B. And remember, the A was already tail, so I don't have to update that. It was already tail. So I'm just putting something in there. So the next one is going to be adding a node in the middle. So we did add at the beginning, we add at the end. Now we're going to do add the middle. So in the middle, so if I have a node and I want to add something in the middle, I have to know where I am. And then I can update the next of this and then the next of the new one. And again, I have to do the next of the new one first before I update the next of the previous one. Otherwise, it's going to get lost. So the steps are going to be, first, we're going to update the next of the new one. Then we're going to update the next of the previous one to connect to this one. So we call it insert after, meaning that we're going to get a node and we're going to insert it after that node. So whatever we are going to be inserting, I'm going to get the previous node. So the parameters that we have, again, self is going to reference to the current instance of the class linked list. Then the current node is going to be what has been created, an object, an address in the memory. And then we're going to have our new node. So the current node is the one that we're going to be inserting the new node after it. We also going to be checking the operator to define if the current node is self-tail. So if the current node is tail, we're basically going to be using the append, and we have to update the tail. Okay, so to start with, we're always going to be checking for the head to be sure is none. If the head is none, we have an empty list. We're always going to be watching all of these things. So first thing first, we want to be sure if our list is empty. If it's empty, we're just going to put head and tail the same thing. So previous two method did the same thing. Now, we're going to check the current node to see if it's going to be the tail. If that's the case, we're going to put the tail next to the new node, and then we're going to put the tail as a new node. Otherwise, we're going to be, so let's look at it that way. And let's go through it. So we have this node C. We create a node C with data 11. And we want to put node C after node A. So when we're calling it, we're going to say our current one is node A. So this would be my current. This is my new one. So we want to put this one right here. Now, again, if I take this next and point it to this one, I'm going to lose the rest of the list. So what I'm going to do is I'm going to update this next first. Then I'm going to update this next. So the head is not pointing to none. So we already know this if the statement is not correct. And we're checking it to see if our current node is tail. So we are using A as a insertion. We're going to be inserting after A. So that's not going to be the case. So we are going to use this one right here. So the new node dot next, which is this one right here. Let me clear this up a little bit. So we are looking at next of this one. We're going to point it to this one. So how do we do it? We're going to say current node dot next. Remember, this is my current node. Okay, so to find what this next is, that's going to be my current node dot next. So I'm going to go there, connect node.next. I'm going to grab this one and I'm going to put it in my next over here. And then I'm going to update the current node next to the new one. So remember, because this is not the last one, I don't need to update the tail. If it was the last one, then we had to update the tail. That would be the middle one right here. Okay, so I'm going to stop right here. I'm going to make another one for part 2. That would be the removing nodes. I'm sorry.